test will be on the 1st of November, which is a Tuesday, after the week. So these are the formulas you will need to remember. Right, so you will need to remember these formulas for the test on the 12th of November. And
I can do this.
okay. So as I said, all the material for the test will be based on definition 1 of extreme values. Everything that we covered on definition 1. You remember, I assume you know what I mean, right? Definition 1, right, of extreme values. All right, now I'm going to talk about what we did yesterday now. Do you have any questions on what we did yesterday, guys? No? Yes? Are you sure? Come on, guys. Don't be shy. You know, I'm here to help you guys. So let me summarize what I did yesterday. So yesterday I started talking about case 4 portfolio theory. So this is where the losses are INID, and the number of investments is a random variable also, right? And I showed you yesterday that the CDF of S, the total portfolio loss, can be expressed like this, and the PDF is the derivative of the CDF, right? Then I derived the CDF of U, which is the minimum portfolio loss. It takes this formula, right? And the PDF takes this formula, right? And then I derived the CDF of V, which is the maximum portfolio loss. The CDF takes this formula, and the PDF takes this formula, right? All right, now before we move on to case 5 and 6, the two remaining cases, I needed to give you some preliminaries, right? So I needed to So the preliminaries, these are preliminaries on the multivariate distributions. These are preliminaries for the bivariate case, where I introduced the joint CDF, the marginal CDFs, the joint survival function, and also the marginal survival functions. Then there is two relationships between the joint CDF and the joint survival function. These two relationships, right? And then I gave you some preliminaries in the trivariate case, where you have a triplet of variables, right? This is the joint CDF. These are the marginal CDFs, and this is the joint survival function. And these are the marginal survival function, right? And then once again there's a relationship between the F and the F bar given by these two formulas, all right? And also how to obtain the joint PDF from the joint survival function or the joint CDF, right? Through one of these formulas, right? Then I talked about the preliminaries for the p-variate case, where this is the definition of the joint CDF. These are the marginal CDFs. This is the joint survival function, and these are the marginal survival functions, and these are the relationships between the f and the f bar, right, the joint CDF and the joint survival function. And finally, these two formulas show you how to derive the joint PDF from either from the joint CDF or the joint survival function. Okay, so then I did an example. This is the example I looked at yesterday. So I gave you this formula and asked you to derive this, right? And the answer, these are the answers that we got yesterday. I hope you understood this. Do you have questions on this or not? Hello, guys. No? If you do, please let me know. Then I gave you a second example. This is the second example. And asked you to work it out. Did you have time to do this or not? I know you guys are busy, but you have time? How you say? You done this?
Yeah, actually, I have.
You have. Good.
I'm sure if you try.
All right. Anyway, if you haven't done it, I will do it now. So I don't want you to like pressure you. I know you have lots of assignments and coursework and all that thing. So, all right. The first part. The first part is to find the marginal survival function of x1. This, if you look at the formula I gave you yesterday, or one of the formulas I gave you yesterday, is equal to this. Is I put 0 here and not minus infinity because the lower end point is 0, not minus infinity, right? So I put 0 in place of minus infinity, right? So if you do that, what do you get, guys? You get all right. So this is the joint the marginal survival function of x1, right? All right. To find the marginal survival of x2, you put, in place of x1, you put 0, so you get this, right? Now remember that this is the marginal CDF of x1. The marginal CDF of x1 and the marginal survival function of x1 should add up to 1. So what would this be? This would be what? Which is x1. Okay. Right? And the next one is to find the joint CDF of x1 and x2. Alright, to do this, I'm going to use one of the formulas I gave you yesterday. right? One of the formulas I gave you is the following. If you look back what we did yesterday, guys, you will see this. Right? So this will be 1 minus right? Are you guys okay so far? And finally is to find the joint PDF. To find the joint PDF, there are two formulas you can use, right? In this case, you will prefer to use the one that involves the joint survival function, because that is easier to deal with. All right, so you will find the partial derivative of this with respect to x1 and x2. So first, with respect to x2, what's the partial derivative of this with respect to x2? It will be minus 1 divided by okay, and the partial derivative of this with respect to x1 will be 2 divided by okay. So this is the joint PDF of x1 and x2. Okay. I'm sure all of you got the right answer, did you? I'm sure it's not a difficult example, right? Any questions on this, guys? Sure. All right. All right. So let me put this here. All right. The next thing. All right. Now I'm going to go back to where we started yesterday. Right now, I mean, we had done the sorry, can you say this? Oh, yeah, you can. We done the preliminaries, so now we can go back to case 5. Remember, we have 2 cases left. We've done case 1 to case 4. So we have case 5 and case 6 remaining, right? So let's start with case 5, where the losses are dependent random variables and the number of investments is fixed, right? So in this case, start with A. The CDF of S, remember S is the total portfolio loss, will be following. here. Right? So the formula for the CDF of S is the integral of the joint PDF, because the variables are no longer independent, so they are all dependent. So what you have to integrate is the joint PDF of x1 to xn over the region, over this region here, right? Okay. Sorry. This is the PDF of S. Right. Okay, guys. Okay. Any questions on this? So let me put this here. Okay. Hopefully you can see this. The next one I'm gonna do is, before I go ahead, let me do like an example 3. Suppose n is 2, right? Then the CDF of S in this case will be this. Okay. So another way of writing this is as follows. So right. This is another way of writing, because we have two variables of integration, right? So x1, the sum being less than or equal to x, means that x1 can go from minus to plus infinity, but x2 can only go from minus infinity to this, right? Is that clear? I mean, just double integration, right? Okay, and the PDF of S, which is the derivative of so now let me ask you, this is where your calculus comes in. You are differentiating this with respect to S. What would you get? You should differentiate this this expression here with respect to s, what will you get? Hmm? Come on, guys. I'm not asking something very difficult. You should differentiate this with respect to s. This is what you will get. Okay. I mean, it's calculus, but you should. I mean, you should have. Didn't you learn in calculus how to differentiate an integral? Like when you differentiate an integral, you just replace. Replace the upper limit here comes to this, so it becomes s minus x1. Right. Okay. All right. All right, guys. Any questions on this or no? I mean, anyway, I don't expect you to derive this, but I expect you to be able to apply these formulas. So maybe I will do some examples later on. Okay. On how to apply these formulas. All right. The next thing is B. Alright. Remember, U is what? U is what? It's the minimum portfolio loss, right? Now I'm gonna write this as, by the complement rule, you can write this as 1 minus this. And this you can write as like this, okay? And this you can write as the probability that x1 is greater than u up to xn is greater than u. Now can you I mean, from what we did yesterday, what is this equal to? Can somebody tell me what is this probability equal to? You should know the answer. This what?
1 minus
Yeah, you're right. This is the joint survival function. This is the joint okay. Yeah. Hmm? Do you guys follow this or no? Yeah? Yes? Okay. So the PDF is just a derivative of that, so it is minus d by du of this, right? Okay. So that's this. Yeah. The next one is part C. The city of V. Remember, V is the maximum portfolio loss, right? So right now, if the maximum is less than or equal to V, then each has to be right. Now let me ask you, what is this from what we did yesterday? From what we did yesterday, can you remember what this is? What is this probability? Is what is it known as? Huh? Joint what? Joint. It's known as the joint CDF, guys. Don't you remember? We already forgotten what we did yesterday. This guy here. This is the joint CDF of x1 to xn. Okay. All right. So the PDF is simply the derivative of that, so it's gonna be the derivative of right. So it's d by dv of the joint CDF. Right? That will give you the PDF of the maximum portfolio loss. Right? Okay, guys. Any questions so far? Are you guys okay so far? Yeah. Right. So that's case 5. I will do some examples later on, but let me also finish because I want to get rid of all the 6 cases. Then I can do a lot of examples. All right. So let me now do the final case of portfolio theory, which is case 6. So case 6 is and n is a random variable, right? So first A, the CDF of S is the probability that right, and this you can write as this. Now this is due to what? What is this result known as? This is known as the total probability rule. Okay. Now this conditional probability here is exactly what we got a few minutes ago. Remember this. This is the formula that we got. This is the formula when the number of investments is fixed, right? So this conditional probability here is the same as this formula here, right? Okay, so what I'm going to do is to replace the conditional probability by this formula here. And then multiplied by the probability that capital N is equal to little n. Alright guys, you follow what I've done. I just simply replaced the conditional probability by this one, right? Right, this is the, so the PDF is simply the derivative, right? Okay, so that's part A. Now I'm going to move on to part B. So part B is the next one. Let me know if you have any questions, guys. Feel free to stop me. The CDF of U once again, this follows, this holds because of the total probability rule. Okay, once again, the conditional probability here is equal to what we did earlier. That's this one here. Remember this one. This is the CDF of U when n is fixed, and we got this expression here. Okay. So what I'm going to do is I'm going to replace the conditional probability by this expression, right? So you will get okay. Now this is, there are two terms here. The first term is 1 to infinity of the probability that n equal to n, and the second term is 1 to infinity of okay. Now what is this term here, guys? I know one of you asked me this yesterday. What is this equal to? 1. Yeah, because this is the sum of all probabilities. It must be 1. So this becomes 1 minus okay. So this is the expression for the CDF of U for case 6, right? Finally, for the PDF of U, is going to be the derivative of this with respect to U. So if you differentiate this with respect to U, guys, what do you get? You will get the following: minus n equal to 1 to infinity in brackets d by du Alright, so this is the expression. So I've taken the derivative inside the summation, right? And the only thing you need to differentiate is the first term, not the second, because second is just the probability. Doesn't depend on U, right? Okay, guys. Any questions so far, guys? Let me know, please. The last one of case 6 is C, right? So here we're gonna look at the CDF of V. Right, is this. And once again, by the total probability rule, you can write this as this, right? So let me write one more time. This is the total. I applied the total probability rule. Right, now what you have here, the conditional probability, is exactly what we got earlier today. Is exactly this one. You remember this one. This is the formula that we got for the CDF of V when the number of investments was fixed. So that's equal to the conditional probability. So what I'm going to do is I'm going to replace the conditional probability by this expression here, right? Alright? Are you guys with me? Yeah? Any questions? Alright, so this is the expression for the CDF of V in case 6. Alright? And finally the PDF of S, sorry, PDF of V is the derivative of this, which is sorry, just I'm being too quick here. It's the d by dv of the CDF of V, right? And if you differentiate this and take the derivative inside, this is what you will get. Alright, so this completes the 6 cases. So with this we are done. We covered all the 6 cases of portfolio theory. Right? So I'm going to do some examples now in a minute. Do you have any questions before that? No questions? I forgot the chocolates today. No, this time I didn't forget. I didn't forget you guys. All the time I don't do it. Good luck. That will bring you good luck. How are you doing? You all right? Did you guys sign the attendance sheet? Where is it?
Yeah, see it.
Oh. Everybody gave it. All right. Let me do some examples. So you have any questions on the 6 cases we did so far? I mean, all the 6 cases we've done. So, do you have any questions on those? Yes? No? Okay, good. All right. Now, all right. Let me start with one example. I know we're running out of time, but I will try to do it as quickly as possible. So suppose this is example number 4. Suppose n is 2, that is the number of investments is 2, right? And right. So this is, this is it carries on from what we did yesterday, right? You have 2 investments, right? And the losses of the 2 investments have this joint survival function, and we want to work out all of this, right? Okay. Now the first thing is to work out the CDF of S. You need to know the joint density function, right? Do you remember the formula? Remember the. Come on, guys, listen to me, please. This is the formula for the joint density function. Sorry, the CDF of S. For the CDF, to find the CDF of S, you need to integrate the density function, the joint PDF, over this region, right? Okay. Now you may remember yesterday. This is an example that we did yesterday, guys. Right? Do you remember what we got for the joint density function? Come on, guys. I'm an old man. I thought you have a better memory than I have. Benji. When you have, okay, let me write it down. Oh. Do you remember what? Do you guys recall where I got this from? Where does this come from, guys? This one here. You do remember? You remember what we did yesterday, guys? Yesterday we found the joint PDF of x1, x2 for this example. And what I have written here is the joint PDF of x1 and x2, right? So you're basically integrating the joint PDF over this region to find the CDF of S, right? Okay, and finding this integral is not difficult, but it will take forever. So I will not waste my time. I will just put a dot 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 dot. You can just complete it, okay? And I hope you don't mind. Okay, and the PDF of S, which is part 2, right? Part 2 is to find the PDF of S. To find the PDF of S, all you have to do is just replace x2 wherever there is a x2, replaced by s minus x1. So you will get zero to infinity, right? Times minus theta x1 dx1. Again, this integral is not easy, but it can be worked out. So I'll just I don't expect you to work out these integrals. They can be worked out, but it's a lot of work though to work out these integrals. So I don't expect you to actually calculate these integrals, right? As long as you know these are the formulas to apply, that's fine, right? Okay. Okay. Are you with me, guys? Do you know how I got this, guys? All I have done is to replace wherever there's an x2 here, I have replaced by s minus x1. So that's how I got this, right? Okay. Some of you look tired. What's happened? The long day or what? All right, part 3, I mean. Part 3, the CDF of U. What is the formula for the CDF of U? Can somebody tell me? I just wrote down a few minutes ago, guys. Don't tell me you forgot already. What is the formula for this? 1 minus. Okay. So this will be 1 minus what?